If you think that humans are destroying the planet in a way that's historically unprecedented, you're suffering from a species-level delusion of grandeur. We're not even the first creatures to pollute the Earth so much that other creatures go extinct. Weirdly, it turns out that's a good thing. If it hadn't been for a bunch of upstart microbes causing an environmental apocalypse over 2 billion years ago, human beings and our ancestors never would have evolved. Indeed, Earth's history is full of apocalyptic scenarios where mass death leads to new kinds of life. To appreciate how these strange catastrophes work, we'll have to travel back in time to our planet's beginnings. The Proterozoic Eon, 2.5 billion to 540 million years ago. Earth is roughly 4.5 billion years old, and for most of its life, the atmosphere would have been noxious for humans and all the creatures who live here now. Vast acidic oceans roiled in what today's environmental scientists would call an extreme greenhouse climate. The air was superheated and filled with methane and carbon. Our planet's surface, now covered in cool water and crusty soil, was bubbling with magma. The solar system had formed relatively recently, and chunks of rock hurtled between the young planets, often landing on them with fiery explosions. One such impact on Earth was so enormous and threw off so much debris that it formed the moon. It was on this poisonous, inhospitable world that life began. About 2.5 billion years ago, early in an eon that geologists call the Proterozoic, a few hardy microbes who could breathe in this environment drifted to the surface of the oceans. These microbes, called cyanobacteria, or blue-green algae, knit themselves into wrinkled mats of vegetation. They looked like black, frothy coats of slime on the water, trailing long, feathery tendrils beneath the waves. All that remains of this primordial ooze are enigmatic fossils that hide inside a distinctive type of ancient spherical rock called a stromatolite. If you slice a stromatolite down the middle, you'll see thin, dark lines curving across its inner surface like the whorls in a fingerprint. These are all that remain of those algal mats. Only a few people in the world would recognize them as the traces of impossibly old life that they are, and Roger Summons is one of them. He's a geobiologist at the Massachusetts Institute of Technology who has spent decades studying the origins of life on Earth, as well as the extinction events that wipe it out. An Australian with a dry sense of humor, Summons has an office you can only reach by walking through his lab, a big, airy room full of tanks of hydrogen and bulky mass spectrometers that look like old-school Xerox machines covered in tubes. When I visited him to talk about ancient Earth, he plucked some slices of stromatolite from the top of a filing cabinet to show me the traces of algae that spidered across their surfaces. This one is 800 million years old, and this one is 2.4 billion, he said, pointing at each ragged half-sphere of rock. Oh, and this one is probably 3 billion years old, but it's a crap sample. Even with a crap sample, Summons can pin a date on the fossils of creatures who lived more than 2 billion years ago by examining the sediments that have preserved them. In his lab, researchers grind up ancient rocks, subjecting them to vacuum, freezing, lasers, and a strong magnetic field before running them through the mass spectrometers. At that point, often nothing remains of a stromatolite but ionized gas. And that's exactly what mass spectrometers need to decode the atoms in each sample. Atoms in minerals decay at a fixed rate, and reading the state of a rock's atoms can tell scientists how long it has been since it formed. Geologists don't put fossils themselves beneath the laser. They use machines like the ones in Summons's lab to figure out the ages of the rocks next to the fossils. Call it dating by association. Knowing when the oldest stromatolites were created helps us date an event which changed Earth forever. The mats of algae that became stromatolites weren't just methane-loving scum. They were also filling the atmosphere with a gas that was deadly to them: oxygen. This is how the first environmental disaster on Earth began. Just like plants today, ancient blue-green algae nourished themselves using photosynthesis, a molecular process that converts light and water into chemical energy. Cyanobacteria were the first organisms to evolve photosynthesis, and they did it by absorbing photons from sunlight and water molecules from the ocean.